Hey students, this is lesson 522. We're going to learn how to use geometric models to multiply binomials. And so we're going to use the idea of the area of a rectangle to do that. So in number one, it says, look at this diagram here, and write two expressions, one for the length and one for the width. So we'll say that the length is this dimension, so we need that length. And so from here to there, and that length is going to be a plus 3. And then the width, you probably figured this out by now, that's going to be a, now remember a just goes up to there, so a plus 2. And then B says use your expression to write an expression for the area. Well, area is just the length times the width. So we can just take our expression for the length times our expression for the width, and that would be a plus 3 times the quantity a plus 2, like that. Okay, and then part C says use your drawing to expand your expression. So in other words, what would this expression look like? All right, so what we're going to do is we're going to find the area of each of the little parts of this rectangle. And so we have this part right here. And to do each of those parts, we just have to know what the length and the width is of each of those parts. This one is A and A, and so length times width would be A times A, or A to the second. This part over on the right side, the width is A, and the length is, or the width is 2 right there. The length is from there to there, that's A again. So length times width would be 2A. Down on the bottom part, we have a rectangle that has a length of 3 and a width of A, so that's 3A. And then the smallest part, for some reason students miss this, but that width there is just 2, same as the top, and then that width there is 3, so it's 2 times 3 is 6 for that part. So we're going to write the area as A squared plus 2A plus 3A plus 6, adding 4 parts together. And we can actually simplify part of that because we have some like terms there. 2A and 3A makes 5A. So A squared plus 5A plus 6. All right. Now, Arturo wanted to expand x times x plus 4 times quantity x plus 3. To do this, he drew a rectangle. X plus 4 units wide and x plus 3 units wide. He then drew lines to break the rectangle into 4 parts. And he wrote the area of the large rectangle equals, and he's talking about this one right here, x plus 4 times quantity x plus 3. Again, length times width. He then found the area of each of the smaller parts and used the area to write another expression for the area of the large rectangle. Finally, he simplified this expression by combining like terms, which is just what we just did there. So our original expression, just using the length and width, is this. And if we find each of the parts there, this part is x times x. This part is 4 by x. This part is 3 by x. This little piece is 3 by 4, which is 12. And then those two terms we can combine, 3x, 4x, when we add it up, we get x squared plus 7x plus 12. Okay? All right. Number 3 says do parts A through C. Do the following. Draw a rectangle diagram to model the product. Use your diagram to help expand the expression. I'll do C with you, because that was probably the hardest one. One dimension is 2n plus 3. The other is n plus 1. I'm going to make this dimension this way, n plus 1. So let's say that line is n. And I'm going to add like one more. So, and that one can be somewhat arbitrary. But so we'll say that's n plus 1 there. So that distance there represents n and one more. Now 2n would be the same distance as my n there, which I think is about there. Then another n. So another n. So there's an n and there's an n. and then plus 3, so we have one more piece on this, a little bit longer than this, than that other piece that was 1. And then I get a rectangle, and I can split it up accordingly from my parts, and it looks like that. And then it says use your diagram to help expand the expression. So, so my one expression is for the area is given right here. The other expression I can get by adding the parts. Well, these two things are squared, so those together make 2n squared. This rectangle right here in the end is 3 by n, so that area would be 3n. This rectangle on the bottom is 1 by n, so that would be 1n, or n. This rectangle here is exactly the same as that. And then the last rectangle in the lower right corner is 1 by 3, which is 3. So now I can get my expression by adding all these parts together. I have n squared twice, which is 2n squared. And then I have n, 1, 2 times there, and then 3 times there, and that makes a total of 5n, and then an extra 3 added on. So you can see we end up with a trinomial when we do that. When you do these other two, if you do them correctly, you should end up with a trinomial also. All right, so a certain rectangle has an area y squared plus 6y plus 3y plus 18. Draw a rectangle diagram that models this expression. All right. Well, that has 4 parts, so we're going to think we have some kind of a rectangle that has 4 parts like the earlier one. So maybe it'll look something like that. And the y squared part would be the big square. I'll put that in for you. And so the dimensions there are y by y. And then the other two, the little square in the corner, that's the one that has the y in it. That's 18. I'm going to put that there. So now you have to think of where you're going to put the other 2 parts. One is 6y and one is 3y. So I'm going to do it that way. And if this area right here is 6y, then that means, and I know that this dimension down here is y because it's the same as this one up here. And that means the other dimension has to be 6 to get 6 times y. And using a similar line of thought, this little part up here needs to be 3. And so, so that rectangle can model that. And we can see from our expression, if we just write length and width, that y plus 3 times y plus 6 is going to be equivalent to y squared plus 6y plus 3y plus 18. And so that's the answer to part B. Y plus 3 times quantity y plus 6. Right? So another rectangle has that area. Draw a rectangle diagram that models this expression. So I'll get you started on that one, and I think I'll let you finish that one in class. But one thing that we noticed when we did those earlier is that we always had 2 things that would simplify to one term. And so, and that would be this part and this part. And the 2 parts we know are the 6 and the y. All right, so that part's y squared and the other part is 6. So now you just have to think of a part here and a part there that add up to 5y. And when you put the dimensions here and here, they multiply to give you 6. So you go ahead and think about that, if you can do it. Okay. And you can answer this question also, why does the final expression for the area have 3 instead of 4 terms? And after a couple of diagrams, you probably realize that there's always 2 terms that you could combine because they're like terms. Anyway, all right. That should do us for the lesson, and we'll do the rest in class. We'll do the share and summarize and work on some practice problems then. See you tomorrow.